Okay, now continuing that previous lecture where I cover recovery manager. Recovery manager mostly it is doing two operations, undo and redo. Okay, for recovery manager, for undo and redo, it needs inputs or log record. Okay, so first recovery manager take two responsibilities. Whenever you are doing some transaction, that log record must be created, because this one will be required for recovery manager. Okay, and next thing is for recovery manager contain one handler object. This handler object responsibility is by seeing the log record, it need to generate exact data. Okay, here transaction is happening. Transaction, what it is doing, we have one data page. To this data page, assuming only for one data page only, transaction is updating the data. Okay, transaction local memory extracted this data page and mutating the state. After mutating state, for each mutation it is generating the log record. This log record required for recovery manager as we cover. So for each mutation, log records are generated. Log record 1, log record 2, log record 3, like that, until final transaction. If it is success, commit record. If it is failed, abort record. These are the log records generated during mutation, whenever mutation happening in transaction. Okay, next, by seeing a recovery manager contain one handler object. That handler object, okay, here state mutation of the record, and it is final output. It is page 1. This page is dirty. First transaction acquire this page and do some mutation and make this page as a dirty. Okay, for dirty page, what are the operation transaction is done to make this page is dirty, all are recorded here. Okay, in recovery manager we have another handler object is there. That object take the responsibility, it do some reverse, that it take the page object and records all log records, process based on the log record, generate final state. That means it is page 1 state 0, page 1 state 1. Okay, process handler also take the log records and page 1 state 0, however it is present the same page here also present. Okay, by seeing this log record, it generates the same how it is in that page 1 in state 2. How it is doing process handler without transaction, it is generating the same state 0 of the page 1 into state 1 of the page 1. How? Without transaction, by seeing this log record. You got it here. Okay, so I am concluding what I said, here page is there, it is in assuming state A. Through transaction, after transaction, that page become as a page B. Okay, this is with transaction. Now process handler is there. It doesn't take input as a transaction, but it take input log record. With log record and page 1 which is in A state, it take the input page 1 in A state and log record and generate the page 1 in the B state, the same state, without transaction. Process handler, by seeing the log record, it is generated. These are the recovery mechanism uses. One is during transaction, log record it is saved, and if state is in this same state, by seeing the log record, recovery mechanism contains process handler object. That object generate the same page. Okay, how it is generated? Through undo and redo. Process handler internally uses undo and redo. We'll cover that one. Now I'm continuing. Now I'm covering discussion. Is I need to discuss one is immediate data modification. Next is defer data modification. Okay, what are those two terminologies? I said this is the page 1 in state 0 or state A, and transaction, after transaction page is in some state 2, state B or state 1, and during transaction log records are there. Okay, now this log record, it is in where? Initially it is in local memory of the transaction. Through write, we are storing log record in buffer memory. Through IO, we are storing log record in hard disk or stable memory. Okay, so what is here? Immediate and defer, these two from the point of log record. How log record is storing in stable memory, either immediate or defer. Okay, here data modification, immediate and defer, we are concentrating based on the storage of the log record. In immediate means, in immediate what it is happening, each transaction, suppose transaction is there, this transaction is generating log records of up to 5. Let us assume this is the 5th commit record. This 5 transaction is there. In immediate, whenever the transaction is generated LR1, record 1, the same time this record is updated in buffer, from the buffer directly simply update in stable memory for each log record. Okay, that means each minor step it is updating in hard disk, in updating in stable memory. Whereas in defer, for each transaction, for each operation, DML operation, this log record is only stored in buffer only, not stored in hard disk. That means stable until transaction is committed. Until transaction is committed, then only it is stored in stable memory or hard disk. Okay, so we'll cover what are the benefits with the immediate and defer later, but default in SQL Server, MS SQL Server, I observe that it is using immediate log record modification. So transaction is not yet committed, it is done to DML operation. For each DML operation, log record is stored in buffer, not only buffer, in hard disk, in a stable memory. So by default SQL Server uses immediate log record. Okay, but whereas defer, it is stored only in buffer memory, it will not store in hard disk, stable memory, until committed of that transaction is happen. Okay, next I need to cover is two things is there. What is compensation record? This is come under undo only, and finally redo operation, then initiate the, and final initiate why we need checkpoint. Okay.